Hi, my name is Jared Schladweiler, and I'm currently involved in the Mechanical Design Technologies program here at Moraine Park. Now, in this speech, I had to do a persuasive or an informative speech, and it was kind of difficult to do a persuasive speech on mechanical design, so I decided to do a little informative speech and explain to the viewers what mechanical design really is. Like most, you might be asking yourself, what exactly is mechanical design? This is a term we hear thrown around daily, or at least I do, and many people have heard it, but people really don't know what exactly it is. As a textbook definition, mechanical design is defined as the following. It is a discipline of engineering that applies principles of physics and material science for analysis, design, manufacturing, and maintenance of any and all mechanical systems. Now, when you think of the term mechanical systems, you think moving parts, and that's not entirely true. Mechanical design could have been put into something as simple as a plate and a bowl, on up to the chairs we sit on when we eat, or the tables we eat at, the cell phones we use to contact our family and friends every single day, to the TV we watch when we want to relax, on up to the vehicles that we drive to get us from point A to point B, or the airplane that takes us on our vacation. In a car, there are thousands of moving parts that work in unison to get the job done, which is get us from point A to point B. If one of these parts should fail, the system as a whole is deemed ineffective and usually needs costly repair to fix. It is up to a mechanical designer's job, it is up to him to figure out the cause of the problem and to develop a new part, better quality part, or something different to fix this issue so it doesn't happen again. At the core, mechanical designers usually design new parts to fulfill a given task, or in some cases they improve on existing ideas. And the idea that comes to my head when I think of improving on an existing idea is the idea of the wheel. This has been something that's been around since 3500 BC. And when it was first developed, it was solid, heavy. Yes, it got the job done, but it wasn't the most effective. It was very time consuming to make, and it wasn't the most smooth ride. Fast forward 1500 years, and we finally developed spokes, which gave it a little less weight, gave it a little better ride, but still wasn't as comfortable as we have in our tires today. Speaking of the tires today, we have developed rubbers and air pressure systems that regulate the tires, which can last for upwards of 40 to 50,000 miles, which gives us a better car ride, and it's least costly. Now, at the start of designing and drafting, a lot of the drawings were done by hand on drafting boards with pencil and rulers. This is a very effective way to do it back then, but it was also very time consuming. It took ample time to get drawings done to send out to customers to get approved. Nowadays, with the technology we have, most of the drawings are done on computer-aided drafting systems, or more commonly known as CAD. And popular CAD softwares are AutoCAD, Pro-E, Inventor, and there's some 3D modeling programs called SolidWorks and Unigraphics that most of the industry uses today. These programs allow designers and engineers to design a part, make a part on there, and not only make it, but they allow them to do the testing without having to actually build the prototype and spend the money on that. It allows us to simulate loads and see if they'll fit, simulate tolerances, and all other anticipated factors of a new part design. Now for a little history on CAD itself. Like I said before the computers, everything was done on hand. Back in the 1970s, the CAD market itself had begun to develop. It was considered new technology, so it was considered unwieldy and was a little too costly for everybody to use, so most avoided it. It required a huge computer to run, and only the biggest of corporations could afford this computer, so obviously a lot of people were left in the dark and stuck with a paper and pencil. In the 1980s, the programs were made to operate on desktops or a lot smaller computers, and the cost of this program had dropped drastically. It became a lot more user-friendly, and it made work a lot easier and less time-consuming, so more and more people picked up this program and started switching over to the CAD programs. As I said before, when a drawing was completed, the drawing had to be physically mailed to the customer to get the customer's approval. This, of course, would take days as the mail system isn't the fastest. With this new technology of a CAD system, the drawings could be sent immediately to the customer via email, and they could get instant approval, and the parts could be produced much quicker. This reduced production time drastically on both ends of the spectrum. As technology has developed, so did the CAD programs themselves. Today, in today's time, most programs have the ability to run 3D, which 3D is a lot nicer. It lets you see the part as a whole, as it really is. I have a few examples of some drawings that I've done on 2D and 3D programs, and I'd like to show them really quick. These are just various parts that I've made. As you can see, there's the 2D views here, and then this 3D view. This 3D view is a view that I actually did not create. The computer software itself created this view. I did the basic views, and the technology in the program was smart enough to create it itself. So that saves a lot of time. Here's just another example of a view. And these are just various parts for different machines. With the 3D modeling, another thing that really helped was the ability to do assemblies. And this right here is a 3D assembly that I've done. And it's a vise that holds a coaster in a production plant. The ability to do 3D models really transformed the industry. It made it a lot easier to make parts and get production out quicker. Now I know that sounds like a lot of words, and you're asking, well, what do you do realistically? Well, I currently work at Sharp Packaging. It's a company that makes pre-open bags on a roll. And with these bags, we sell machines to take our bags, package a product, seal them, and send them off to be shipped. Recently, we were contacted by a customer because the customer was having a problem with one of our machines. Excuse me. The machine that we had sent them, its design purpose was to package ballpoint pens, send them into a bag, and seal the bag to be sent. I got a demonstration here to explain what had happened. The customer, this is the bag, the customer's machine was spitting the pens off, coming in vertically. They were fitting 10 pens to a bag, sealing them, and sending them off. Every now and then, what had happened was a pen was getting caught and would fall horizontally. This caused the other pens on top to back up, and this caused a lot of downtime with having to clean out the excess pens, and it created a mess because the pens would spill out on the floor. So they contacted our engineer, and his main objective was to devise a part or create a part that would funnel these pens in so they would go in vertically every time. Although it took him a little while to figure this out, the job was completed, and he succeeded in developing this part, and the customer has not had any problems with this since. And as I said, mechanical design is not only developing new parts, but it is working on already created machines such as the example I just gave. All around us, we deal with mechanical design, and it's something as a whole that it's a vast study. It involves a lot of trial and error and a lot of hands-on activity. It's something that most know and most are around and most experience every day, but have never really took the time to think about it. With that being said, I think if most people would take the time to notice, they would realize what is all around them and what is all entailed in mechanical design. They realize that there is a lot that goes into it, and they deal with this on a daily basis. It's not such a foreign concept as people think. With that being said, this concludes my speech. Thank you very much.